Imagine getting into your car on a Friday morning, tapping home, and then basically not touching the wheel for 3 days while it takes you across state lines, through construction zones, into busy downtown streets, and even across an international border. That's not a demo ride with an engineer in the passenger seat. That's a regular owner driving from Seattle to Portland, over to Vancouver, Canada, and back, while the car does almost all the real driving. That just happened. And it wasn't in some future prototype. It was on Tesla's new full self-driving version 14.2. In the last few days, Tesla has quietly done 3 things that, put together, might be the real turning point for autonomy and for Tesla's entire business. First, they pushed a huge update to FSD, version 14.2, and it's already rolling out wide to owners. Second, their AI leadership started openly warning legacy automakers that most of them will not survive unless they basically build cars for autonomous platforms like Tesla. And third, Elon Musk revealed just how far ahead Tesla actually is in designing its own AI chips, with a goal so aggressive it sounds like a joke until you realize he's serious. Today, we're going to break all of that down in plain language. What FSD 14.2 is actually doing differently, what 14.3, being the last piece of the puzzle, really means, why Tesla is hiring people to squeeze big AI models into older hardware, and how their in-house AI chips could completely blindside companies like NVIDIA and the traditional automakers. And most important, what it means for you as a driver and as an investor. So buckle up, because if you've been on the fence about Tesla's autonomy story, this might be the moment where the pieces finally click. Let's start with what changed in FSD 14.2, because this isn't just a minor polish update. On paper, the key line in the release notes sounds dry. Tesla upgraded the neural network vision encoder, leveraging higher resolution features to further improve scenarios like handling emergency vehicles, obstacles, and human gestures. In plain English, the car's digital eyes just got sharper, and its brain is now better at understanding what those eyes are seeing. Think about what that actually means. It's not just recognizing a car or a lane line. It's recognizing a police officer in a reflective vest waving you through an intersection. It's noticing a delivery driver half-stepping into the road and predicting they might walk out. It's seeing an ambulance with lights on from farther away and adjusting your lane and speed earlier instead of reacting at the last second. Owners who are running 14.2 are already noticing it. One driver talked about running it through heavy construction, parking lots, and highways, and the main word he used was smooth. No random braking, no panicky moves, and fewer moments where the human has to grab the wheel because the car got confused. That doesn't mean it's perfect. There was a case where the car got stuck trying to leave a parking lot and needed a nudge. But here's what matters. The number of weird failure cases is shrinking, and the quality of everyday driving is crossing a psychological line. Here's that line. Is this good enough that I'd trust it with my mom? One of the guests in that original conversation compared FSD to large language models like the one you're hearing right now. LLMs can have flashes of brilliance, but they still hallucinate and say completely wrong things with a straight face. FSD, on the other hand, is making millions of tiny decisions per drive, with a far higher accuracy requirement, because the outcome is physical. Either you get home safely, or you don't. You can forgive a chatbot for a bad answer. You don't forgive a car for a bad left turn into traffic. With version 14, especially 14.2, Tesla is starting to push into a strange new zone, where the car's consistency is making seasoned owners say, "This actually drives better than I do." One Tesla owner in Vancouver told a story that captures this perfectly. He was on a busy 4-lane road where the left lane is faster, but constantly gets clogged when someone decides to turn across traffic. FSD, running 14.2, spotted a car way ahead blinking to turn left and quietly slid into the right lane before the slowdown even formed. It made the move earlier than a human normally would, and it did it without drama. That's not just staying between the lines. That's strategy. That's reasoning. Now, this is where Elon's comment comes in. When an owner posted a glowing review of 14.2, Elon replied that 14.3 will be the last big piece of the puzzle. What does that actually mean? In software development, there's a concept called feature complete. It doesn't mean the product is perfect. It means all the major building blocks are in place. From that point forward, you're fixing edge cases, smoothing rough spots, and scaling. For FSD, the missing piece has been deeper, real-time reasoning. The ability for the system to not just see and react, but to plan, to change the plan when the world changes, and to do it in a way that feels natural to human passengers. You can already see glimpses of that in 14.2. One owner described sitting at a left turn with heavy traffic that just wouldn't brake. After waiting, the car simply turned off the left signal, flipped on the right one, and decided, I'll turn right and do a U-turn instead. That's exactly the sort of workaround a human driver might choose if they were thinking ahead. So when Elon says 14.3 is the last big piece, the implication is this: vision is good enough, planning is good enough, and reasoning is about to catch up to the level where Tesla feels comfortable calling this true door-to-door robo-taxi capability, at least in certain cities and conditions. And here's the part most people miss. It isn't just about how smart the software is, it's about how fast Tesla is able to improve it. Look at the cadence. Version 14 launches in October, 14.1.7 lands in November, 14.2 drops in the back half of November and starts rolling to owners almost immediately. Owners report that their Model X and their Cybertruck both get 14.2 within an hour of each other. That used to take weeks. That tells you three things. First, Tesla has unified its software platform enough that a massive update can now push across very different vehicles quickly. Cybertruck is not a Model 3, but it's now on the same FSD branch without huge delays. Second, their internal testing and quality gates are getting tighter and more efficient. You can't ship more often with more changes if your testing is bad. That only works if you've streamlined how you verify releases and how you roll them out. Third, sentiment is shifting, and Tesla is absolutely watching that. Modern consumer companies scrape sentiment from platforms like X, forums, and app reviews. They don't just look at raw star ratings. They track positive, neutral, and negative mentions around specific features and specific versions. If you graphed the sentiment on FSD version 12, 13, and 14, the early data suggests version 14 is a step change. Fewer horror stories, more "this is finally good" posts. That doesn't mean critics disappear, but it does mean Tesla is seeing green lights to go wider, faster. Now, while this is happening on the software side, there's another story unfolding that might be even more brutal for traditional automakers. A senior Tesla AI executive recently said something that legacy boards should probably have printed and framed in their boardrooms. His warning was straightforward. For most legacy automakers, the only realistic path to survival in an autonomous world is either to build vehicles for the companies that win autonomy or to scale back massively. In other words, if you don't have your own world-class autonomy stack and your own AI compute, your future looks a lot like being a contract manufacturer. That's a brutal downgrade for companies that have spent a century owning the whole stack: brand, dealership networks, marketing, financing, the works. And here's the problem for them. They already struggled with the first phase of this transition: electric vehicles without autonomy. Many legacy brands jumped into EVs when government money started flowing. They made big announcements, opened new plants, promised dozens of models. But when the stimulus faded and they had to actually make EVs profitably, it got ugly. Many of those plans quietly shrank. They pivoted back to hybrids. And then they pushed a new talking point: people just don't want EVs. Meanwhile, Tesla kept dropping prices, improving range, and making the cars better with software updates. Now autonomy is tightening the screws even further, because autonomy attacks the real economic core: price per mile. It doesn't matter whether you own the car, rent it, or hail it as a robo-taxi. If Tesla can offer a safer, smarter ride for fewer dollars per mile because they own the whole stack from chip to software, everyone else gets squeezed. You can't fix that with a marketing campaign. You can't fix it by saying, "We're listening to what consumers want," while shipping another warmed-over crossover. And this is where the hardware story becomes critical. If you think this is only about software models running in the cloud, you're missing half of Tesla's advantage. Over the weekend, Elon finally pulled back the curtain on something they've been doing quietly for years. He revealed that Tesla has had an advanced AI chip and board engineering team in-house for a long time. That team has already designed and deployed several million AI chips in Tesla cars and data centers. The current generation in cars is called AI 4. They're close to taping out AI 5. Work on AI 6 has already started, and the goal is to bring a new AI chip design into volume production every 12 months. If that sounds more like a smartphone company than a car company, that's exactly the point. Then he said the line that made everyone stop and reread it. He expects Tesla will eventually build AI chips at higher volumes than all other AI chips combined. That's not a throwaway brag, that's a roadmap. Think about everything Tesla wants to put real-world AI into. Cars running FSD, Optimus humanoid robots in factories, warehouses, and maybe homes. Dedicated inference boxes and data centers. Robots and vehicles used by other companies. Every one of those needs a brain. And Tesla doesn't want to be entirely dependent on NVIDIA or any other external supplier for that brain. The other key detail here is how they're doing it. They're not just designing chips in isolation and then handing them to some random software team. Tesla's AI AI chips are co-designed with the software teams from day one. The chip designers, the AI software engineers, and the people working on physical products like airbags, crash sensors, and robot joints are all in the loop together. That's vertical integration at the engineering level. As one of Tesla's AI leaders explained, their autopilot computer can process and understand about 1 million pixels of streaming video in around 1 millisecond. There's no big software stack overhead. Everything from the camera sensor to the neural network to the control output is optimized to keep latency as low as possible. Why does that matter? Because in the real world, latency isn't abstract. Latency is the difference between avoiding a collision and being too late. Latency is the difference between an agile robot that can work next to humans and a clumsy one that's always a step behind. Most companies don't have that setup. They buy hardware from one vendor, middleware from another, and then try to glue their own software on top. Every layer adds delay. Every handoff adds complexity. Tesla, on the other hand, can take feedback from a crash test, or a strange FSD failure, or an Optimus motion test, and bring that directly back into both the software and the chip design cycles. That's why their engineers talk about tokens per watt, or value per watt. They're trying to squeeze the maximum real-world intelligence out of every unit of power and every dollar spent on silicon. Now let's tie this back to a group that's been feeling pretty anxious lately: owners of cars with Tesla's older FSD hardware, what many people call Hardware 3. If you're in that group, you've probably worried that you'll be left behind while the new hardware runs the latest and greatest models. The recent news is a strong signal that Tesla doesn't want that to happen. They're hiring AI distillation engineers specifically to take large models that run on the more powerful AI4 hardware and compress them into smaller, more efficient versions that can still run in real time on Hardware 3. Distillation is like teaching a smaller student everything they need to know from a much larger teacher, and then sending that student out into the world with a lighter backpack. Why would Tesla bother? Because there are millions of Hardware 3 vehicles already on the road. If even a fraction of those can be upgraded by software to run a distilled version of FSD 14 level intelligence, that's a gigantic business opportunity. More cars that can subscribe to FSD, more potential robo-taxis, more happy customers who feel like Tesla kept its promise to them. That's not charity, that's good business. Tesla executives have reportedly told owners directly that Hardware 3 can still be used for robo-taxi. And when you put that together with the distillation hiring and the overall confidence you're hearing, it looks less like a vague hope and more like a serious internal project. So where does all of this leave us? On the surface, it's a blur of version numbers, chip names, and job postings. But step back and a simple picture emerges. On the software side, FSD 14.2 is the first version that feels, to many owners, like it's crossed a threshold. The car isn't just staying in its lane, it's making smart, human-like decisions more often. And it's doing it across states and even countries. On the iteration side, Tesla is shipping major updates faster to more vehicles with fewer show-stopping bugs, while watching sentiment rise instead of fall. On the business side, Tesla's own AI leadership is essentially calling time on the idea that legacy automakers can just coast into the autonomous era. Without world-class AI and in-house compute, their best option may be to become suppliers to companies like Tesla. And on the hardware side, Tesla is building a pipeline of AI chips that, if they hit their targets, could put them in a league of their own on volume, latency, and performance per watt. Put all of that together, and you start to see why people are quietly using the word tipping point. Not the flashy, one-day headline kind of tipping point. The slow, uncomfortable realization in boardrooms and engineering departments around the world that Tesla isn't just a car company dabbling in software. It's a real-world AI company that happens to have started with cars. So here's the question I want to leave you with. If Tesla keeps moving at this pace, and if FSD 14.3 really does pull in that last big piece of the puzzle, how long will it be before regular drivers start expecting this level of intelligence as standard? The same way we now expect smartphones to navigate, stream, and update themselves. And when that happens, what happens to the companies still selling $60,000 vehicles that drive almost exactly like they did 10 years ago? Let me know what you think in the comments. Do you believe Tesla is actually on the verge of true robo-taxis? Or do you think there's still a big unsolved gap here? If you found this breakdown helpful, hit that like button so more people see it. Subscribe for more deep dives into the future of cars, autonomy, and EV investing, and stick around, because in the next video we're going to talk about how these AI chips and robo-taxis could completely change what your car is worth over the next 5 years.